Hi, this video is about the one sample t-test in PSPP. We're gonna calculate the mean and the standard deviation of our sample from this data here, and we're gonna compare it to a population mean. So if you look at the formula of the one sample t-test, if we look here, we're looking at the sample mean minus the population mean. So we're looking at this difference, and then we're dividing it by the standard error of the sample. So the standard deviation of sample divided by the square root of the sample size. So we can calculate everything except the population mean. So the population mean we're going to need to retrieve from records or test manuals, or calculate it exactly from the population. And you do that, the one sample t-test, again by comparing means. Analyze, compare means, one sample t-test. We're choosing the ACT score as our variable, test variable. We don't need to do the group because we're using all the individuals. And then you see here the test value. It is the empty field, so it requires you to input a value. Now we looked up on the ACT.org database, we've seen that the average for the US is 21.1. So we use that as our population mean for the comparison with the US sample. Okay. And we're going over here in the output. We see, okay, first that's where I got my file. That's where I saved it. And then we see the t-test. The t-test value that we test we use for our one sample t-test is 21.1. That's what we typed in, right? The variable used is ACT, and we used the 95% criterion for the interval, for the confidence interval. Now, for our sample statistics, that's what we calculated. Our n was 20. We got a mean of 24.75, a standard deviation for a sample of 5.19, and then the standard error of our mean was 1.16. So then we do the t-test, the one sample t-test, and you see that the test value that we're using for the population, again, 21.1. You see the difference between 21.1 and 24.75 is right here, the mean difference, 3.65. So that we can see, okay, that worked out all right. And with the degrees of freedom of 19 and the t-value of 3.15, we get a two-tailed significance of 0.01. So we can see that the significance is smaller than 0.05. So we can say, even if we tested, if we had a non-directional hypothesis, we can say there is a significant difference between the mean of the sample and the population mean, and thus we reject the null hypothesis. We go with the alternative hypothesis, and we conclude that our sample is statistically significantly different than the population mean. Now, let's go to the second part of the question that we had in this worksheet 4.3, which was, how does the sample compare to the state, California? So again, we go into one sample t-test, we use the ACT score, we click it over, and now we type in the test value for the population of California, right? The question, I mean, not the whole population, but whatever students form the population of California for this test. And we looked up the records and we found that California was a little bit higher than the average, the national average, so it was 22.1. So we see the difference is going to be a little bit smaller. Okay. We'll go back over here. Right, so now we go to the second part, and you see this time in the syntax, the test value is 22.1. Everything else here, sample statistic, is the same, right? We didn't change anything there. But now we compare the one sample t-test to 22.1. So the mean difference is now 2.65. Remember earlier it was 3.65 up here. The t-value is thus also a little bit lower, 2.218, still same degrees of freedom, and now the significance 0.03. So you see, significance is a little bit it's a little bit less significant, but it's still below 0.05. So here also we would reject the null hypothesis, and we would conclude that our sample is significantly higher than the California population sample. This was the one sample t-test in PSPP.